continental drift theory, and plate tectonics theory. The structure of the Earth can also be defined and divided based on how the insides of the planet behave. Thereby, the mechanical layers correspond to the physical or mechanical properties of these layers. The mechanical layers of the Earth are differentiated by their strength or rigidity. The lithosphere is the outermost and most rigid mechanical layer of the Earth. It includes the crust and the top of the mantle. This is divided into pieces, called tectonic plates. The movements of these plates are responsible for mountain building, oceanic trench formation, earthquakes, and volcanic eruption. The Asthenosphere is located underneath the lithosphere. It is about 100 km thick, and is a region of the mantle that flows relatively easy, but it is not liquid. The asthenosphere includes the soft layer of the mantle, on which the lithosphere moves. It is made of solid silicate materials, but the high temperature allows it to flow very slowly. The Mesosphere is located beneath the asthenosphere. It encompasses the lower mantle, where material still flows, but at a much slower rate than the asthenosphere. The high temperature, but intense pressure in this region, restricts the movements of materials and substances, which makes it extremely rigid. The outer core is the only layer of the Earth that is a true liquid. Furthermore, its movement is responsible for generating the Earth's magnetic field. The inner core is made of iron and some nickel. However, unlike the outer core, it is a solid ball. The solidity is due to the intense pressure from the upper layers. The first to observe continental drift is Abraham Ortelius, a key figure in the history of cartography. He is also the inventor of the Atlas, a book comprising multiple maps in one format and style. Abraham Ortelius's first published atlas was called the Theatrum Orbis Terrarum, which also means the theater of the world. This was first printed in 1570. It featured a collection of 53 maps, all in the same style and size. It was printed from copper plates, and arranged by continent, region, and state. The Theatrum Orbis Terrarum Atlas featured his most famous, Deposition Orbis Terrarum. It covers the entire world from pole to pole, revealing the shape and size of continents, based on the knowledge of the time. Ortelius designed the map, according to previous world maps from other cartographers, but he also added new information based on his own guesses and estimates. Abraham Ortelius is the first in history to observe the continental drift. He writes, "The coastlines of the continents are so similar, that they seem to have been torn apart, at some point in time." The similarity in the coastlines is very well visible in Ortelius' atlas, when looking at the Latin American and African coasts. Abraham Ortelius' hypothesis remained silent for several centuries, until a German climatologist, Alfred Wegener, proposed the continental drift theory. Wegener was a German meteorologist, geophysicist, and polar researcher. In 1915 he published The Origin of Continents and Oceans, which outlined his theory of continental drift. Alfred Wegener proposed a theory that the continents had once been joined, and over time had drifted apart. Wegener came up with this idea because he noticed the similarities in the coastlines. The coasts of Western Africa and Eastern South America looked like puzzle pieces, which might have once fit together, and then drifted apart. Wegener theorized that the continents had once been joined together as a supercontinent around 225 million years ago. This was later called Pangaea. The name Pangaea comes from the ancient Greek words, pan, meaning entire, and Gaia, meaning earth. Fossils of similar types of plants and animals found on the shores of different continents, suggesting that the continents were once joined. Fossils of Mesosaurus, a freshwater reptile, have been found both in Brazil and Western Africa. Also, fossils of the land reptile Istrosaurus have been found in rocks of the same age in Africa, India, and Antarctica. Lastly, fossil remains of Synognathus, also a reptile 3 meters long, was discovered in the shores of South America and Africa. Also, several warm weather plants and animal fossils have been found in ice-covered regions. This climate-related evidence also supports the continental drift theory. Fragments of an old fold mountain belt, between 450 and 400 million years ago, are found on widely separated continents today. Pieces of the Caledonian Fold Mountain Belt are found in Greenland, Canada, Ireland, England, Scotland, and Scandinavia. The theory of plate tectonics builds on Wegener's theory of continental drift. In the theory of plate tectonics, it is tectonic plates which are moving, and not the continents. Here's how plate tectonics work. The rising and diverging mantle convection currents push plates apart, allowing magma to feed the mid-ocean ridge. Also a part of the plate tectonics, is the sinking, and converging, mantle convection currents, that pull plates together, and cause subduction. Then the rising and diverging mantle convection currents, also split the continental crust, creating a rift valley. The Earth's outermost layer is fragmented into a dozen or more, large and small solid plates or slabs, called tectonic plates. The plates are constantly in motion relative to one another, as they ride atop the hotter and more mobile material, known as the Asthenosphere. The Earth has 58 crustal plates, and 15 major tectonic plates. The primary plates comprise the majority of the landmass of the world's major continents. The 7 major or primary plates are African Plate, Antarctic Plate, Eurasian Plate, Indo-Australian Plate, North American Plate, Pacific Plate, and the South American Plate. Tectonic plates move land masses, or continental crust, and oceans, or the ocean crust. And these plates are constantly moving, and bumping against each other. Also, the sizes and positions change over time. Tectonic plates are able to move, because the lithosphere, which makes up the plates, has a higher strength and lower density than the underlying asthenosphere. The solid plates above move along on the liquid rock below. You may imagine that these plates are fast zipping along, but in fact, they are moving very slowly. The speed of the plates ranges from a typical 10 to 40 mm per year, to as fast as 160 mm per year. Tectonic plates can have 3 kinds of motion across boundaries. They can move away from each other like at a divergent boundary. They can move toward each other to make a convergent boundary. They can slide past each other horizontally at a transform boundary. In a divergent boundary, 2 plates are moving apart, and new crust is created by magma pushing up from the mantle. A convergent plate boundary is where crust is destroyed as one plate slides under another. There are 3 types of convergences. In an oceanic convergence, a trench is formed. The continental convergence form mountains in an oceanic continental convergence, and a mountain range is created. A transform plate boundary is more commonly known as a fault. While most transform faults are found on the ocean floor, a few, such as the San Andreas Fault in California, occur on land.